Hey everyone, ready to dive into large language models,
Yeah.
LLMs. We've got a ton of research here, articles, all sorts of stuff to help us figure out this whole landscape.
Yeah.
It's changing so fast. But you might be surprised to hear this. LLMs, they aren't exactly brand new.
No, not really.
Like, think about it. Predict the
Yeah.
text, right?
Yeah.
On your phone. Or when your smart speaker,
Mm-hmm.
understands what you're asking it, it's all using some of the same basic ideas behind these big LLMs.
Yes, that's right. But the thing is, what sets these LLMs apart is just the massive, scale of it all.
Mm-hmm.
The complexity. We're talking systems trained on, huge data sets of text, even code. And they can generate, human quality writing, translate languages, even write creatively. Different kinds of stuff.
So for this deep dive, what we're aiming for is like a concise but, still insightful explanation of how these things actually tick.
Yeah.
Especially for, our developer listeners out there.
Yeah.
Because you're probably running into this tech more and more these days. So maybe a good place to start is just with the basics. Like LLMs, at their heart, they're all about probability.
Exactly.
Right.
They're trying to predict how likely it is to see a certain word or a bunch of words together in a specific context.
So it's almost like the LLM is thinking, okay, given all the text I've devoured, if I see the cat sat, the next thing, the most likely thing is on the mat.
Precisely.
Yeah.
Predicting that next word, that most probable next word based on, like you said, all that text data. And, to see how we even got here, maybe we should take a little trip back in time.
Okay, time travel and a podcast.
Yeah.
Sure, why not? Lead the way.
All right. So one of the, earliest ways people tried to model language was using something called n-grams.
N-grams, okay.
Which are essentially sequences of words. Think of it this way. Imagine someone trying to write a story, but they're only looking at the last, 2 or 3 words they've written.
Uh-huh.
So they might be able to string together some simple sentences, but the story itself, not going to make much sense.
Right, yeah.
Yeah.
I can see how that would get pretty limited pretty fast.
Exactly.
So how do we go from, these little word sequences to the LLMs we have today?
Well, the real game changer, neural networks.
Oh, yeah, neural networks?
These networks are, modeled on the human brain.
Yeah.
And they can learn these complex patterns from data, including language data. And instead of just looking at words right next to each other, neural networks, they can actually capture connections between words that are much farther apart, even across whole paragraphs.
Uh-huh. So it's like our brains, but, digital. Our brain's digital doppelganger or something.
Kind of, yeah.
It sounds like neural networks brought a whole new level of, understanding to the party.
Exactly. And the way they learn is fascinating, too. They're trained on tons and tons of data, and they're constantly adjusting their internal parameters, kind of like those little knobs and dials, to better understand the patterns of language, almost like teaching a child to speak. By just, giving them thousands and thousands of examples of conversations and writing.
Okay. So these neural networks, they're learning from this massive amount of data, and they're tweaking their little internal settings all the time to try to get all the nuances of language.
Yeah.
And I'm guessing the bigger the data set, the better the network gets.
Right. Absolutely. But
Yeah.
even with neural networks, there were still limitations.
Wow.
The early networks, they processed words one at a time in sequence,
Uh-huh.
which made training slow and very, very resource intensive.
Yeah.
And that's where transformers came in.
Transformers.
Yeah, introduced back in 2017.
Okay.
And they revolutionized things because they allowed for parallel processing.
Parallel processing. Okay.
So instead of reading a sentence word by word, transformers can look at the whole thing all at once,
Uh-huh.
analyzing all the relationships, no matter where the words are.
So it's like they can see the bigger picture. You know what I mean?
Exactly. And that made training a lot faster. And we could use even bigger data sets. Remember how we were talking about the human brain before? Well, one of the biggest LLMs out there, it was actually trained on a data set that's basically the whole internet.
Whoa, the whole internet.
Yeah, all of Wikipedia, all the books, code, scripts, everything. It's kind of crazy.
That's wild. So that's why these models can, sound so human, right?
Right. But it's not just about, shoving in more data.
Okay.
These transformers, they have to actually learn how to understand language.
Right.
So one of the main ways they do that is something called masked language modeling.
Masked language modeling.
Think of it like a fill-in-the-blanks game. The transformer gets a sentence, but some words are hidden.
Uh-huh.
And it has to guess what the missing words are based on all the words around it.
So, the blank jumped over the blank moon. And it has to figure out cow and lazy.
Exactly. That forces the transformer to really get the meaning of the sentence, not just individual words. It's got to consider grammar, the context, even common sense.
Wow. So it's amazing they can pick up on those little cues and connections that, like, we don't even think about as humans. Yeah, it is.
And I bet this kind of training makes them super versatile, right? Can do all sorts of things.
Oh, yeah. And it's not just filling in the blanks. You can also train them to judge if, say, sentence B actually follows logically from sentence A.
Okay.
So then they can start to understand things like cause and effect, argumentation, even storytelling.
Whoa, like they're learning to think critically, analyze information, and make connections. That opens up so many possibilities.
Right. And that brings us to another big thing about modern LLMs, their sheer size.
Okay.
Like we call them large, for two reasons.
Yeah.
First, the amount of data they're trained on is just astronomical. We're talking trillions of words, sometimes more.
Trillions.
And second, the size of their neural networks. They can have billions, even hundreds of billions of parameters.
Hold on, back up a sec. We talked about parameters before. Can you remind folks what those are and why they even matter?
Sure. Think of them like the knobs and dials that control how the neural network processes everything.
The more parameters you have, the more finely tuned the model can be.
Okay.
It's like a sound mixer with tons of sliders.
Oh, yeah.
Each slider changes the sound a little bit. Parameters work kind of like that.
Gotcha. So more parameters, more precise, more nuanced, all comes back to understanding language better.
Exactly. All that data, combined with these huge neural networks, lets LLMs capture all this nuance and complexity in language. But even with all that under the hood, they wouldn't be that useful if we couldn't actually interact with them, right?
Right, right. And that's where prompts come in. Those are the questions or instructions we give to the LLM to guide it, essentially.
Exactly. Think of it like giving the LLM a starting point, a specific job.
Okay.
And systems like ChatGPT, they're actually trained to respond to prompts using something called reinforcement learning.
Reinforcement learning.
Okay.
That sounds familiar. Isn't that how, like, computers learn to play games?
That's right. It's all about trial and error,
Uh-huh.
where the model is rewarded when it produces outputs that make sense to us humans. Like, imagine a dog learning a trick. Right. Yeah.
They get a treat when they do it right.
Right.
Same idea here.
Yeah.
You ask ChatGPT a question, it gives a good answer, it gets rewarded.
Yeah.
So over time, it learns to do things that are more likely to get rewarded.
That's fascinating. I bet our developer listeners are starting to see how prompts could be used to build some really cool tools. But we got to talk about the elephant in the room here. The cost of all this.
Yeah, oh.
What elephant? Training these models must take a ton of computing power, right?
Yeah.
And energy.
Oh, absolutely.
Yeah.
It's a valid point. Training these big models can cost hundreds of millions of dollars in computing resources.
Wow.
And all that computing power, it means a lot of energy consumption.
Carbon emissions, too. Some estimates say the CO2 emissions from training one large LLM are like driving a car across the U.S. hundreds of times.
Hundreds of times.
Yeah.
So there's definitely a trade-off here. We're getting these super powerful tools, but we also have to think about the environmental impact. It really does. Makes you think. But okay, let's bring it back to what we've learned today. Well, we started with like those simple n-grams, just looking at those little word sequences.
Right.
Then we have the neural networks come in, and suddenly we can analyze how words relate across sentences.
Mm-hmm.
And then, boom, transformers, parallel processing, massive data, the whole internet, basically. It's been a wild ride.
Yeah, it really shows how fast this field is moving. And the thing is, we're just getting started with what LLMs can do.
So let's think about our listeners,
Yeah.
especially the developers out there. Knowing all this about LLMs now, how do you see this tech-changing software development?
Well, imagine LLMs that can write code in different languages
Whoa, okay.
and generate documentation, like automatically.
Wow.
Or even debug really complex systems. Like, what if you had an AI assistant that could understand your code,
Okay, yeah.
suggest how to make it better, even predict bugs before they happen?
That's incredible. LLMs could completely change how we think about software development.
Absolutely. They could automate all those boring, repetitive tasks, you know?
Yeah.
Make development way faster. And that means developers can focus on the creative stuff, the strategy, but it's not just about automation either.
Right.
Imagine LLMs that can look at user feedback, suggest design improvements, even personalize the user experience. The possibilities are huge.
It sounds like LLMs are going to be a must-have for developers.
Yeah.
And if they understand how these models work, they can use them better.
Yeah.
and even help build the future of this tech.
Exactly. It's not just about understanding, it's about seeing the potential
Yeah.
and being part of what comes next.
So to all our listeners, especially you developers out there, I say dive in, explore, experiment. The world of LLMs is huge, and it's changing every day. Who knows what amazing things you might discover. Thanks for joining us in this deep dive into the world of large language models. We'll catch you next time.